Chapter Motion in Straight Line. Question: derive the equation of uniformly accelerated motion by graphical method. Now at t is equal to 0, the velocity of the particle be v0, and at t is equal to t, the velocity of the particle be v, which is shown in the figure. Therefore acceleration a is equal to slope of line AB. You can see in figure triangle ACB, slope of line is AB. Therefore A is equal to BC upon AC is equal to V minus V0 upon T minus 0 is equal to V minus V0 upon T. Therefore V is equal to V0 plus AT, equation 1. Now displacement of the particle during T is equal to the area of region OACD in V versus T graph. You can see in figure OABCD. Therefore V minus V0 is equal to AT, equation number 2 from equation 1. Therefore X is equal to area of rectangle OACD plus area of triangle ACB. Therefore the area of rectangle OACD is equal to OD into OA is equal to T into V0 is equal to V0T. Area of triangle ABC is equal to 1/2 AC into BC. Therefore AC is equal to OD is equal to T, and BC is equal to V minus V0, equation number 2. Therefore V minus V0 is equal to AT from equation number 2. Therefore area of triangle ABC is equal to 1/2 T in bracket V minus V0 bracket over. Now keeping both the value, we can get here X is equal to V0T plus 1/2 AT into T is equal to V0T plus 1/2 AT square. Therefore X is equal to V0T plus 1/2 AT square, equation number 3. But average velocity X is equal to in bracket V plus V0 by 2 bracket over into T, equation 4. For equation 3 and equation 1, T is equal to V minus V0 upon A. Therefore X is equal to bracket V plus V0 by 2 bracket over, and next bracket V minus V0 by A bracket over. Therefore V square minus V0 square plus 2AX, equation 5. Above equation can be written as follow: V is equal to V0 plus AT, X is equal to X0 plus V0 T plus 1/2 AT square, and the last 2A in bracket X minus X0 bracket over is equal to V square minus V0 square. A particle with initial velocity V0 moves with constant acceleration in a straight line. Find the distance travelled in nth second. For given particle, distance travelled in nth second is d is equal to bracket distance travelled in n second bracket over minus next bracket distance travelled in bracket n minus 1 bracket over second bracket over is equal to in bracket V0 n plus 1/2 a n square 1 bracket minus bracket V0 in bracket n minus 1 bracket over plus 1/2 a in bracket n minus 1 whole square bracket over. From equation D is equal to V0 t plus 1/2 AT square is equal to in bracket V0 n plus 1/2 a n square bracket over minus next bracket V0 n minus V0 plus a by 2 next bracket n square minus 2n plus 1 bracket over next bracket over is equal to bracket V0 n plus 1/2 a n square minus V0 n plus V0 minus 1/2 a n square plus a n minus a by 2 bracket over is equal to V0 plus a n minus a by 2. Therefore D is equal to V0 plus a by 2 in bracket 2n minus 1 bracket over. For the object falling freely, V0 is equal to 0. What is free fall? Question mark. Write equation of uniform accelerated motion for object falling freely. The acceleration produced in the object due to gravitational force is called gravitational acceleration. This acceleration is in downward direction. If the air resistance is neglected, then this type of falling of the object is said to be free fall. Here, acceleration is considered as a negative gravitational acceleration. This is also an uniform accelerated motion. Equation of the motion with constant acceleration with a is equal to minus g. It will be v is equal to v0 minus gt. X is equal to v0 t minus 1 half at square. V square minus v0 square is equal to minus 2 ag. For free falling body, initial velocity v0 is equal to 0. As above equation will be v is equal to minus gt minus x is equal to minus 1 half gt square. Therefore, x is equal to 1 half gt square. P square is equal to minus 2gy in bracket minus y bracket over is equal to 2gy, which are equation of motion for freely falling body. Which are equation of motion for freely falling body. Draw graphs A versus t, v versus t and x versus t for object falling freely. You can see here the graph of A versus t for object falling freely. Acceleration is constant and equal to negative g. Thus, graph A shows the change in acceleration with respect to time A versus t. Second graph, velocity of the object freely falling v is equal to minus gt. Thus, the graph of B is obtained for v versus t, you can see in figure. And third graph for object falling freely, h is equal to 1 half gt square. Thus, the graph C is obtained for y versus t. When the brakes are applied to a moving vehicle, the distance it traveled before stopping is called stopping distance. Suppose the velocity of the moving vehicle is v0 after applying brakes. Retardation is equal to minus a. Distance covered is equal to ds stopping distance. Final velocity v is equal to 0. In equation, v square minus v0 square is equal to 2ax. Therefore, 0 minus v0 square is equal to 2 in bracket minus a bracket over next bracket ds bracket over v is equal to 0, a is equal to minus a and s is equal to ds. Therefore, v0 square is equal to 2a ds. Therefore, ds is equal to v0 square upon 2a. Here a is value of retardation and it is constant. Thus, stopping distance is proportional to square of the initial velocity. Therefore, ds proportional to v0 square. What will be the stopping distance if the initial velocity is doubled? Stopping distance ds proportional to v0 square. Therefore, ds2 upon ds1 is equal to v0 2 whole square upon v0 1 whole square is equal to 2 whole square is equal to 4. Stopping distance become 4 times. On what factor does the stopping distance depend? Question mark. Stopping distance depends on initial velocity of the vehicle and capacity of applied brake on vehicle. On what does the reaction time depend? Question mark. Reaction time depends on the situation and the person. The position of object moving along x-axis is given by x is equal to a plus b t square, where a is equal to 8.5 meter, b is equal to 2.5 meter per second, and t is measured in second. A, what is its velocity at t is equal to 0 second and t is equal to 2 second. B, what is the average velocity between t is equal to 2 second and t is equal to 4 second? Question mark. A, x is equal to a plus b t square. Differentiating with respect to time, dx by dt is equal to 0 plus 2bt. Therefore, v is equal to 2bt. Velocity at t is equal to 0 second. v0 is equal to 0 meter per second, and velocity at t is equal to 2 second. v2 is equal to 2 into 2.5 into 2 is equal to 10 meter per second. b position at t is equal to 4 second. x4 is equal to a plus b in bracket 4 whole square is equal to 8.5 plus 2.5 into 16 is equal to 8.5 plus 40 is equal to 48.5 meter. Position at t is equal to 2 second. x2 is equal to 2 plus b into 2 is equal to 8.5 plus 2.5 into 4 is equal to 8.5 plus 10 is equal to 18.5 meter. Average velocity v is equal to x4 minus x2 upon 4 minus 2 is equal to 48.5 minus 18.5 upon 2 is equal to 30 by 2. Therefore, v is equal to 15 meter per second. A car moving along a state highway with speed of 126 km per hour is brought to a stop within a distance of 200 meter. What is the retardation of the car assumed uniformly? How long does it take for the car to stop? Initial velocity of the car v0 is equal to 126 km per hour is equal to 126 into 10 power 3 upon 3600 is equal to 35 meter per second. Final velocity of the car v is equal to 0. Distance covered by the car before it stops d is equal to 20 meter. Constant acceleration a is equal to ? Time taken to stop t is equal to ? Now from v square minus v0 square is equal to 2ad. Therefore, a is equal to v square minus v0 square upon 2d. A is equal to 0 minus 35 square upon 2 into 200 is equal to minus 35 into 35 upon 400. Therefore, A is equal to minus 3.06 meter per second square. Retardation is equal to 3.06 meter per second square. Now, from V is equal to V0 plus 80, 0 is equal to 35 plus in bracket minus 3.06 bracket over into T. Therefore, 3.06 T is equal to 35. Therefore, T is equal to 35 upon 3.06. Therefore, T is equal to 11.44 seconds.